Today we discuss about the pointers. So pointer is a kind of variable. That variable can hold address of another variable. That is pointer variable point another variable. Such variable called as pointers. Ordinary variable can store only one value at a time. Ordinary variable can store only one value at a time. For example, integer a equal to 25, so that a value is assigned to a, 25 is assigned to a, then we assign 30 to a, that is a equal to 30. The existing value 25 is replaced by 30. So only one value can stored in ordinary variable, but array variable can store more value at a time. If we declare integer a of 10, so it allocates 10 locations, 10 integer location. Each location can hold one integer value. So in that it is a single array variable, that is integer a of 10. A is a one variable name, only one variable, but that variable can hold 10 values, that is integer a of 10. So this is array variable. So ordinary variable can hold only one value at a time. Array variable can hold more value at a time, but pointer variable can store address of variable at a time. Pointer variable is a kind of variable. That variable can store address of another variable. For example, integer a equal to 25. A is an integer variable, so it occupies 2 bytes. So it is a 2 bytes. This is a location for a. This is a location name. 25 is a value at location. That 700 is a address. So each and every byte has integer address. So that address is assigned by operating system at the time of booting. This kind of processing is called memory management. So at the time of computer booting, by using any one operating system, for example Windows operating system, it read complete memory, that is main memory, RAM memory. For example 4GB in our for computer 4GB main memory. So that 4GB it accessing 4GB mean that is it converted into bytes. So for approximately 4GB into 1024 into 1000. So into 4GB into 1000, it is a MP. If we multiply by the again 1000, it is KB. Again 1000, it is bytes. So each byte operating system assign a integer address, integer value as address for each and every location, each and every byte of the RAM memory. So at the time of compilation, C compiler asks 2 bytes. If we declare integer a equal to 25, at the time of compilation, then execution. At the time of execution, the compiler asks 2 bytes from operating system, because operating system is the whole responsible for the memory management. So at the time of execution, compiler asks 2 bytes for a variable. So operating system allocate the available the free memory. So it has some occupied and unoccupied memory that managed by operating system. So it allocate free memory, 2 bytes memory to variable a. So this is a variable name. This is the value at location. This is that address. That address is not given by programmer. So it is given by operating system at the time of memory allocation. That address managed by operating system. So 700 is a address for 1 byte, but internal operation, compiler take only 700. If it is integer type, so it continuously take 2 bytes, that is 700 and 701. Suppose it is a float, the address is 700, but it continuously take 4 bytes if it is a float, 700, 701, 702, 703. So this is a ordinary variable, integer a equal to 25, a is a variable name, 25 is a value at location, 700 is a address given by operating system at the time of execution. So integer star b, this is a pointer variable. If you put star before the variable, this is pointer variable. This variable is a pointer variable. It can hold address of another variable. Example b equal to and a. B equal to and a. So ampersand symbol represent the address of variable. So ampersand symbol represent the address of variable. So and a, that is address of a. What is address of a? 700 is the address of a. That 700 is assigned to b. This is a b location. So integer star b, it allocates 2 bytes of memory. It may be an integer pointer variable or float pointer variable. It may be any type of pointer variable. that has only 2 bytes because all address are in integer format. All integer pointer variable can store address. So all address are in integer format. So the all pointer variable size should be 2 bytes. So B size is 2 bytes. So that is 800. B equal to AND A. That AND A means that is address of A. What is address of A? 700. That 700 is assigned to B. So B is a location name. In that B is a pointer variable. This location is eligible to store address. So if we assign AND A, that address 700 is assigned to B as address. So 800 is the address of B. That is each and every variable. That is, it may be a pointer variable or ordinary variable. It requires some memory space. That memory space is allocated by operating system at the requisition of compiler at the time of execution. So B equal to AND A, that the address of A is assigned to 700. That 800 is the address of B. B address is 800. So here we assign address of A to B. That 700 is assigned to B. So this is a pointer variable. At the time of declaration, if we put star before the variable, that variable called as pointer variable. In this example, that is integer A. It is a ordinary integer variable. So it occupies 2 bytes of memory by the help of operating system at the time of execution. So then we assign, for example, if we assign A equal to 54, that value 54 is assigned to A. So A is a location name, 54 is a value at location, 200 is a address. So here float B, this is a float variable. So it occupies 4 bytes. That 4 bytes is allocated by operating system at the time of execution of C compiler. So it occupies 4 bytes. So it also has some address. That is, this is an integer one. 200, 201 is this location address. It occupies 2 bytes. But for internal operations, it take only first byte address 200. Here also it take only 400 is a first byte address, but it is a float variable. It requires 4 bytes. So each and every byte has a address. So 400, 401, 402, 403. That 4 bytes addresses are addresses for B, variable B. If we assign B equal to 67.56, that value is assigned to NB. 54, 67.56 are all stored in internally binary form only. For our example, we take a decimal value, but internally it's stored as binary. So it is a location, this is a location value, 400 is a address. This is another type, character C. So C is a location name. So allocate only 1 byte because the size of character is 1 byte. So it allocate 1 byte. It also has some address. So the 700, but it access only 1 byte. So the 700 is the address. So 1 byte, the size of address is 1 bytes. So it is a value at location. For example, C, if we put C equal to, within a single quote we put star. That star is assigned to C. But the star is not directly assigned as a symbol. It converted into ASCII format. It is stored in only binary internally. For our easy understanding, we put directly integer float character. So these are the different data types. But each and every data type address are in integer format only. Integer variable address also in integer. Float variable address also in integer. Character variable address also in integer. The value only differ. Integer value. So without decimal point. This one is a with decimal point. A letter, that is an alphabet or a symbol or a numeric digits. Within single quote is a character. So we put only 1. So addresses of all type of data types. All addresses of all data types is in integer. Address of all data type of a variable is in integer. It may be integer variable or float variable or double character. It may be any kind of data type. But that address is in integer format only. So integer A, just if we assign A equal to 54, A is a location, 54 is a value at location, 200 is assigned by operating system at the time of execution, that is 200. So amber symbol is address. So if you want to get address of a variable, just we put ampersand symbol to before the variable name. So ampersand symbol is the address of variable. If you want to get address of a variable, just we put ampersand symbol before the variable. We can get the address of variable. And then the star. Star represent the value at address. If we have address, we want to get the value of the address, just we put the star before the address. So star represent the value at address. So ampersand represents the address of variable. So that star has different meaning. If we declare at the time of declaration, if we put star before the variable, that variable is a pointer variable. At the time of accessing, that is assigning, and then printf, calculation, equation, then these areas are accessing area. At the time of accessing, the star has different meaning. That is value at address. At the time of accessing only, star represent a address, value at address. At the time of declaration, star is pointer variable. Star refer a pointer variable. Here is a address of value at address because it is accessing area. In previous example, we put star at the time of declaration, so that represents the pointer variable. If we put star between two variable or constant, so it is a multiplication. So based on that location, the meaning will change. At the time of declaration, if we use star at the time of declaration, this is pointer variable. At the time of accessing, we put star before a variable, this is value at address. At the time of calculation, we put star between the two variable or constant, this is called multiplication. In this program, just main integer a equal to 54. So it allocate 2 bytes, that 54 is assigned to that location. For example, we assume the address is 200, 201 is that address, but internally it take the first byte address 200. So printf %d is just a. What is the a? A is 54. It is a location name. By location name we put %d, it display 54. Then and a. What is the meaning of ampersand symbol? Ampersand symbol is a address of a. If we put ampersand symbol before the a, we can get address. So and a, that address in integer format. So we put %d. A is integer, so that only we put %, not only d. If it is a float variable, if we take address, we must give %d as a format specification. Because all type of variable, the address of all type of variable is in integer format. So % and a. What is address of a? 200. So 200 is displayed. So star of and a, there is what is and a, address of a. Address of a is 200. If we put star before the address, it get value. So what is the address of value of 200? Value of 200 is 54. It display 54. What is the difference between this first a and last star of and a? This get the value through location name. Internally, that location name is only for that is location name for human only. But internally, computer consider only address. So if we give a, computer refer a, then it get address for a, then it get the value. It do two operations. One is it get address for a, then get the value from that address. But this we can get only value. But internal process is two operations. One is it take address, then take value from address. But in this case, we get directly value. So we give address. So compiler directly give the value. So for example, if we want to take a book from a college library, first we want to pay the fee in colleges, we give a register number or roll number. This is very easy to find our identity. That is register number is easily identified. But if we give name, it is tedious work. Based on that name, the name are repeated. So name is equivalent to location name. Address is equivalent to register number. So this is an example for address and location name. Use register number to get book in library. This is using address. We get value using address. If we get books by using name, so this is equivalent to get value by location name. Integer a, so it is an ordinary variable. For example, a equal to 54, that 54 is assigned to that location. A is a location and 54 value at location, 200 is a address. In integer b equal to and a. B is also a ordinary variable, but it has 2 bytes. It has 2 bytes. If we try to assign address of A and A, so and A means that is 200 is assigned to B. The 200 is assigned to B. The location size is 2 bytes. The address is in integer format. The location is 2 bytes. So easily assigned to that location. But it is stored as value. It not stored as address because B is a ordinary variable. Ordinary variable can store only value. In this case, we assign address to the ordinary variable. So it converted into value. So ordinary variable can store only value. If we try to assign address of another variable, that address converted into value. All the characteristics of address has removed. In this case, integer star c equal to and A. That star c is a pointer variable. At the time of declaration, if you put star before the variable, that variable is a pointer variable. So c is a pointer variable equal to and A. Here we assign address of A in ordinary variable. That ordinary variable store only value. So we try to assign address, it converted into value. All the characteristics of pointers are removed. But in this case, it is a pointer variable. C is a pointer variable. The size is also 2 bytes. All pointer variable size is 2 bytes because all type of variable address is in integer format. So integer star c equal to and A. That and A, what is and A? That is 200. The 200 is assigned to C, but it is stored as address because C is a pointer variable. Pointer variable can store address. If we try to assign value, it converts as address because pointer variable can hold only address. Here we assign address and A. And A means that is 200. 200 is assigned to C. That location size is 2 bytes. This size is also 2 bytes. B size is 2 bytes. C size is 2 bytes. But B is a ordinary variable. It store value only. If we try to assign address, it converted into value. C is a pointer variable. It store only address. So here we store address. So it treat as address. All the characteristics of addresses remain in that area. Float B equal to 19.5. So P is a variable name, 19.5 is a value. It also has some address. It is given by operating system at the time of booting by the requisition of compiler at the time of execution. So that is 600 is a address, but it is a float one. So the first byte address is 600. It continuously take 4 bytes. That is 600, 601, 602, 603. So that is 19.5. Then Q is a pointer variable. Q is a pointer variable. All pointer variable size is 2 bytes because all type of variable address is in integer format. So that's why that size is 2 bytes. But it is a pointer variable. Here we assign address and P. P is a ordinary variable. We assign address and P mean that is address of P is 600. That 600 is assigned here. But that 600 is assigned as address. But that address, but Q is a integer pointer variable. P is a float variable. Q is an integer pointer variable. But it has 2 bytes. We can store only integer address. Integer pointer variable can store only integer address. If we try to assign float address in integer pointer variable, in this case, we assign float variable address into integer pointer variable. That 600 has converted into integer address, not float address. Integer variable, address of integer variable. That 600 is assumed as the address of integer variable. But in our case, 600 is the address of float variable at the time of accessing by using Q. If we access the value of P by using Q, we cannot able to take 19.5. That is, it will not access 4 bytes because it is a integer pointer variable. Integer pointer variable can hold only address of integer variable. In this case, we assign float variable address into integer pointer variable. So that float variable address has converted into integer pointer variable at the time of accessing by using Q. It accesses only 2 bytes, not 4 bytes. So we want to assign float variable address into float pointer variable, float star r equal to and p. This one is valid because r is also 2 bytes, q is also 2 bytes. Q can also store address, r can also store address, but q can store address of integer variable, r can store address of float variable at the time of accessing. So by if we try to access the value through r, it take 4 bytes, but through q it take only 2 bytes. Only 2 bytes we cannot able to take 19.5 because 19.5 occupy 4 bytes. But in this case, if we access the value of p through q, it takes 601 only. So it will not give the correct value. It may be a garbage value. But in this case, r is a float pointer variable. It can store address of float variable. So here we assign address of float variable. So that is 600. If we access through r, it will take 4 bytes. So integer pointer variable can hold address of integer variable. Float pointer variable can hold address of float variable. Double pointer variable can hold address of double variable. So all type of variable address are in integer format. All type of pointer variable size is in 2 bytes. But we cannot able to assign another type variable address into other type pointer variable. So this is the concept. The similarity is there. That is, all type of variable address is in integer format, all pointer variable size is 2 bytes, but at the time of assigning, it's stored as address, but at the time of accessing, it access based on the type. So 2 bytes or 4 bytes based on the data type. So we assign integer variable address of integer variable into integer pointer variable, address of float variable into float pointer variable. This example, that is integer a equal to 54 star b. This is a pointer variable. B is a pointer variable, integer pointer variable. So it can hold address of integer variable. B equal to and a. So address of a. In previous example, a address is assumed as 200. So that 200 is assigned to b. What will be the output? That is a and a, b star b. So a, it is 54. It is a typo. It required 4% d because 4 variable is there. We want to put another percentage d. It is a typing error. So output is a 54 and a address of a 200 star b value 200 is 54. The next program, integer a equal to 54 star b, float c equal to 19.5 star d, b equal to and a, d equal to and c. That is one integer variable, integer point variable, float variable, float point variable. B equal to and a, b is a integer point variable. Here we assign address of integer variable. D is a float point variable. We assign address of float variable. So printf and a and b. So in our previous example, it is a 700. Based on the previous example, 200, 700. That is a address is 200, b address is 700. So size of b, size of d. That is a is a the size of b, size of d. So b is a integer point variable. D is a float point variable. What is the size? 2 bytes, because all type of pointer variable is in integer form. So it all type of variable, the address of all type of variable is in integer. So all type of pointer variable can store address only. So all type of pointer variable in the size of all type of variable is 2 bytes only. So b is a integer pointer variable, d is a float pointer variable, but it gives size of 2 bytes, because all variable, all address, that is address of all variable is in integer. All pointer variable can hold address. So address is in integer format. So it requires only 2 bytes. So it may be any type of pointer. B is a integer pointer, D is a float pointer, but it so 2 bytes, D also 2 bytes. Print up percentage D percentage F. At the time of accessing only we put percentage D percentage F. Here D is a float pointer variable, but here we put percentage D because it will give only integer. So that's why we put percentage D. In this case first percentage D, because B is here 200, value at B 54. So it is integer value. D is a pointer variable. So just a D 700, value at 700 19.5. So it is a float. At the time of accessing only format specification is differ. At the time of accessing address, it may be any type. We put only percentage D's. Pointer arithmetic. So we can add the value with pointer variable. So we can subtract the value from pointer variable. So we understand through this example. A main character M star CH, integer P comma star I, float Q comma star F. That is, we assume base address of S is the double S. This is a array variable. So it has only 3 values, 14.5, 17.5, 19.5. It is a double array. So we assume the starting address, base address of the array is 200. That is, address of S of 0 is 200. Then address of S of 1 is, it is a double, so 8 bytes, 208. The 17.5 starting address is 208, and the 19 is 216. Double star A comma star B. Double star A comma star B. CH equal to and M, I equal to and P, F equal to and Q. So CH is a pointer variable. CH is a character pointer variable, I is a integer pointer variable, F is a float pointer variable. Then we assign character variable, address of character variable is assigned to character pointer variable. Address of integer variable address is assigned to I. So that address is assigned. For example, that is, this is a 200. Then print a percentage D percentage CHIF. So it display CH display address of M, I display address of P, F display address of Q. So what will be the output? 500, 700, 300. Just we assume. That is, CH address is, that is M. Address of M is 500. Address of P is 700. Address of Q is 300. That 500 is assigned to character pointer variable. That 700 is assigned to integer pointer variable. That 300 is assigned to float pointer variable. Just through this printf, it displays 500, 700, 300. Then here we increment CH plus plus, because CH, I, F, these are all the pointer variable. CHS plus mean, and that is, it is increased by 1. CH equal to CH plus 1. CH is a pointer variable. It's not a ordinary variable. It is a pointer variable. It store only address. It's not value. So it is a address. So CH is a character type pointer variable. If we add 1, so it jump to next location. What is the next location? What is the size of character? 1 byte. So CHS plus plus mean, example 500 is a address. CH equal to CH plus 1. If I add 1 with 500, so it goes to next location, that is 501. I plus plus, it is a pointer variable. What is the size of pointer variable? 2 bytes. If we add with 1, what is I? This I is a integer pointer variable. I hold address of P, that is 700. If we add 1 with 700, it go to next location. What is the next location of pointer? 702. 700 is a location, first location. If we add with 1, it go to next location, that is 702, because it is a integer address. It is a character address. If we add by 1, it go to next location is, that is 1 byte. The size is 1 byte, so it goes to 501. Integer 700, but to add by 1, so it goes to next location. It is a 2 bytes. The size is 2 bytes, 702. The F is a float pointer variable. It stored float variable address 300. If we add by 1, So 300, it goes to next location, that is 304, because the size of float is 4 bytes. So if we add a value with pointer, it increase location by location, it not value by value. So location by location, that is 500 is 501, 700 702, 300 is 304. Next case percentage d percentage, it display like that, 501, 702, 304. CH equal to CH plus 2. Here we CH equal to CH plus 2. I equal to I plus 2. F equal to F plus 2. Here we give percentage CH. What is the value of CH? CH is no output here. For CH plus 2 means that is already CH is 501. If we add 2, it is 503 only, because each location has only 1 byte. In 702, I is 702. If we add 2 with 702, it add 2 location, that is 706. Add by 1, 704. So add with 2, 706. A float, already that F is 304. If we add 2 with 304, so 2 means that is 312. The next 304 next location is, the next location of 304 is 308. What is the next location of 308? Because it is a float, we add 4 bytes. So it move next location, 2 locations. So 304, then 2 locations means 312. So it jump next location only, not value. If we add 500 with 1, it is a character or it is a 501. If I add 500 plus 2, so it 502. Suppose if it is integer address, if we add 1, 702. If we add 2, 704. It is a float. It is a 300 float address. If we add 1, 304. If we add 2, 308. Here A comma B, B minus A. So here A equal to and S of 0. In A is a pointer variable. It is a double pointer variable. B is also a double pointer variable. Here we assign the address of double locations. That is and S of 0. In our case, we assume the starting base address of S is 200. So the 200 is assigned to A. What is the first location is 200. The second one is 208, because it is a double. 200, 208, 216. So and S of 2 is 216. S of 0 is 200. S of 1 is 208. S of 2 is 216. So A is 200, B is 216. Just we put AB, that is 200, 216. B minus A, here we subtract pointer from pointer. B is 216. In our case, B is 216 minus A is 200. 216 minus 200, it will not give 6. 216 minus 200 give only 2 location, because it is a double type. So the size of double is 8 byte. So 216 minus 200, the 216 minus 200, it will not give 16. It give only 2 locations. So it give only locations. In pointer arithmetic, it give only, it consider only locations, not value. We are also compare the pointers. Pointer variable can be compared, provided both variable point to elements of same data type. Same type of pointer variable. We can compare the same type of pointer variable. For static integer ARR, so this is one of the array, 10, 20, 30, 67, 56. So integer star I star j. In this case, integer star I star j, it is an integer type pointer variable. I equal to and ARR 4, it is a valid one, because it is a array. Array is an integer type. ARR 4, 0, first location, second location, third, fourth. That is a fourth location. For example, that address is 200. For assume the starting address 200 means it is integer 200, 202, 204, 206, 208. The last one is 208. So and ARR 4 is 208. That 208 is assigned to I, because I is a integer pointer variable. So K equal to ARR plus 4. ARR is also refer the starting address of that array. And ARR of 0 is equal to ARR. If we give ARR, it is also refer the starting address of that array. And ARR of 0 is also refer the starting address. So both are same. If you put and ARR of 0 or ARR, In this case, just ARR. What is the ARR? In our case, we assume the starting location is 200. So 200 plus 4, as per the pointer arithmetic, it is integer type. So it jump 4 locations. That is 400 plus 4 locations is 8, because each location 2 bits. So 400 plus 8, 408. That 408 is assigned to K. So K is 408. I is, that is 208. ARR is a 200. 200 plus 208. K is 208. I is 200. Here we if we compare two pointer variable, but both are same data types, so we can compare it. We cannot able to compare integer pointer variable with float pointer variable. We can compare both variables point to element of the same data type. So I and K are integer pointer variable, we can compare. So what is in our case, I is 200, K is 208. So 200 equal to 208, the condition is false. So it not equal, display not equal. So this output is a previous example output. This is also typo. Just we leave it. So the output of this program is not equal. So we can compare the two pointer variable, but that two variables should be in same data type. We compare two pointer variable, two pointer variable, but that should be in same data type. So pointer arithmetic, that is valid and invalid. What are the valid? What will be the invalid? So pointer plus value. We can add value with pointer. In previous case, just pointer variable, for example, B is a pointer variable, CH is a pointer variable, we put CH plus plus. CH equal to CH plus 2. So it increase 2 locations. So pointer plus value. We can add value with pointer. We can subtract value from pointer. We can subtract pointer from pointer. In previous example also, we subtract pointer from pointer. And pointer comparison, we compare pointer comparison. So we can not only equal to, we put greater than, less than, greater than or equal to, less than or equal to, it will work. And in pointer comparison, we can give all type of relational operator. So invalid, these are invalid. We cannot able to add pointer plus pointer, because pointer has one address and another pointer also has one address. So if we add two address, it will maybe out of the range. It will cross the out of the range. So it causes error. So we don't add pointer with pointer. We cannot able to multiply value with pointer. It is also reach the range. So pointer star pointer. Even pointer with we cannot able to add pointer plus pointer. It will reach mean. So we cannot able to multiply pointer with pointer. So pointer plus pointer is not possible. Pointer multiplication by value is also invalid. Pointer star pointer invalid. We cannot able to divide pointer by value. Even pointer division is not possible. Multiplication and division is not possible in pointer arithmetic. In addition, we cannot able to add two pointer. We can add value with pointer, but in subtraction, we can subtract value from pointer, we can subtract pointer from pointer. In both multiplication and division we cannot do. Pointer into pointer with value, pointer with pointer is not possible in multiplication and division. Dynamic memory allocation. So what is a dynamic memory allocation? In previous cases, if tickler the syntax of C is the rule of C programming structure. First we declare the variable, then we define the statements, then we give the statements. After the declaration only statements. After the statements we cannot able to declare. This is the structure of C. That is the rule of C programming. First we declare the array variable. For example, if we declare integer a of 10, it allocates 10 locations. At the time of execution, we cannot change the 10 location. At the time of execution, we require only 5 locations. The remaining 5 location, the memory of remaining 5 locations is is not used. It unnecessarily allocated. If we at the time of execution, if we need more than 10, that is 15 locations, we cannot use 15 locations. It is a fixed one. At the time of declaration, if we give integer a of 10, it allocate only, at the time of execution, it allocate only 10 locations. We can use or if we use or not use, it's not a problem. But it allocate only 10 locations. If we use 5 locations, the remaining 5 will be waste. If we use more than 10, it is not possible. So in array, we cannot change the array size during the program execution. This type of memory allocation is called static memory allocation. At the time of declaration, we declare fixed locations only. We cannot modify at the time of execution. This kind of memory allocation is static memory allocation. By using mallocate, callec function, the two function is there, mallocation, so callec. By using two functions, we can increase or decrease the size of the memory at the time of execution. This type of memory allocation is called dynamic memory allocation. At the time of execution, we can reduce or increase the memory location as per the user requirement. So this kind of memory allocation is dynamic memory allocation. That is, we allocate memory on the fly at the time of execution dynamically. So that's why it called as dynamic memory allocation. So the difference, two function is there in C language. We can allocate memory by dynamically. We can allocate memory at the time of execution. That is, we can allocate dynamic memory allocation through two functions, M allocation and C allocation. What is the difference between M allocation and C allocation? So in M allocation, C allocation, M allocation has only one argument. At the time of function calling, so we pass only one argument in M allocation. But C allocation, we pass two arguments. Then continuous memory allocation, through if we declare memory allocation through malloc, so it allocate continuous memory location. If it is not available continuously, it will give insufficient memory error. So it continuously allocate memory. In the C allocation, discontinuous memory allocation, it split the required locations. It may be more than one. If we want to allocate 100 bytes, it first allocate 50 bytes in one locations, then allocate another 50 bytes in another memory locations. It is discontinuous memory location. So this is a continuous memory location. If we need 100 bytes, it should available in a same area, continuous area. But in C allocation, it will split it. The third difference is default value is garbage value. That if we declare memory through M allocation, the default value, the initial value of that variable is garbage. That is unpredictable value. If we declare memory, that is, if we allocate memory through C allocation, the initial value, that is default value, is 0. This is the difference. So based on the difference, if we want to declare more memory, we use C allocation. If we want to declare less memory, we use M allocation. So this is an example for dynamic application. Main integer avg, comma n I star p sum equal to 0. These are the variable. Printf enter the number of cells. Through this program, we get the different number of cells. Then we find the average of cells. So we get the number of that is, we get input as sales quantity. We get sales quantities, then we get average for the sales quantity. This is a program. So here we declare dynamically, that is, printf enter the number of sales, we get n. Based on that input, it allocate memory at the time of execution, that is on the fly, it allocate the memory. If we give 10, it allocate 10 locations. If we give 20, it allocate 20 location at the time of execution. It's not a fixed one, it is a dynamic one. So if we put 5, for example, if we put enter the number of cells, it will display. If we put 5, so the value of n is 5. P equal to integer star malloc. Here we use malloc function. Malloc function has only one argument. Here 5 star 2, because we need to allocate location for integer. So here we put 2. If we want to get float value, here we put 4. Double mean we give 16, and that is 8. So in our case we get integer value only. So 5 integer value, that is enter the number of cells 5. 5 into 2. So it pass only one value. In our case the value of n is 5. 5 into 2, 10. The value 10 is passed to the malloc function. It is a inbuilt function, library function. So it passed 10. So it allocate 10 bytes. Here we put 5 into 2, 10. It allocate 10 bytes. That 10 it allocate 10 bytes by the help of operating system. So it has some address. 10 bytes, each and every byte has address, but internal process it get only starting location address, starting address. For example, in our case 200, we assume that is 200. It allocate totally 10 bytes. So 200 to 209. 200, 201 is a first location. 202, 203 is a second location. So it allocate 200 to 209. But it return starting address. It allocate 10 bytes, but it return the starting byte address 200. So it return only generic type of address. Generic address mean it is a typeless address. It return typeless address because M allocation is not only to allocate integer variable, integer variable. So M allocation is not only to allocate memory for integer variable. It's suitable for all data types. So it designed like it return generic address, that is typeless address. If we here we put 4, say allocate 5 into 4, 20 bytes. So it's written the starting address of starting byte, but that address is not specific address, specific type. It is a typeless. Then we convert it into float, but in our case we allocate to store integer value. So we convert integer star. So M allocate function return typeless address. Here we typecasting into integer address. That integer address is assigned to P. So P is hold the address. In our case 200. The 200 is typeless at the time of returning. Then it converted into integer address. Then that integer address is assigned to integer pointer variable. If we want to allocate float, here we put star 4. Then it return typeless address. Here we convert float star. Then this pointer variable should be float pointer variable. But in our case, through this example, we get only integer value. We want to allocate for integer values. We allocate memory for integer value. So integer pointer variable P equal to it return typeless address. Then it converted into integer address. It hold P. If P equal to null. If no memory, that is memory allocation is failure, the no memory is available, it had any issues, the memory is not allocated, it will return null. Null is a null pointer represent the no address, that is no allocated. The 0 is a 0 represent the no value, null represent the no address. So it will not allocate, it return null. The P hold null. P equal to null, the condition is true. Suppose if it is written, the memory allocation failure, it will return null. That null is assigned to P. The P hold null. Null equal to null, condition true. Memory allocation failure, exit. It come out the program. Because without the memory allocation, we cannot able to take the value, we cannot able to do the processing, we cannot able to get the output. So here we so in our if allocate the memory, for example, it allocate 10 bytes, it return 200, it is a type address, it converted to integer address, then it assigned to P. So P is a 200 equal to null, condition false, it skip the if statement. Then it execute 5 times because n is a 5, I equal to 0, P plus I, what is the value of P? 200 plus 0, 200. So scanf, we put ampersand symbol if it is a ordinary variable, but it is a pointer variable. It already it give address, so we don't put ampersand symbol before the variable in scanf because P is a 200 plus 0, 200. So it get a value and stored it into the location of address 200. So for example 20 is assigned to the location of 200. Then the loop is continue. The I is increased by 1. The new value of I is 1. P is 200. 200 plus 1, it skip next location because P is an integer point variable. It skip to next location. 200 plus 1, 202. So the 202, so it get another value 30. That 30 is assigned to the location of 200. That is 202. Then I is 2. 200 plus 2, 204. The 50 is assigned to the location of 204. Then 206. The 208. So at the time I value is 5. 5 less than 5. The condition false. It's come out. So it get 5 values. It assigned to that same memory location. The memory location continuously. Then we get the value. Sum equal to sum plus star. So this is also typo. Here we put star of P plus I. Here we put star of P plus I. Just we put like this, but we put star. Star of P plus I. First P is a 200. The first value I is 0. 200 plus 0, 200. The value at 200, 20. The 20 is assigned to sum. The default value of sum is 0. So it is add 20. Then it continue I 1. So star of P plus I, that is 200 plus 1, 202. The value 202, 30. 30 is added with existing value 20. Then 50 is assigned to sum. Then it continue. Then star of P plus 2, that is 204, 206, 208. That it get the all value. Then it add with sum. So it come out after the fifth loop. It come out. The summation of 5 values, that is 20, 30, 50, 100, 200. So the summation of 5 values, the 200 is assigned in sum. So after come out the loop, the value of sum is 200. 200 divided by n is 5. So 200 plus 5, 40. The 40 is assigned to AVG. So it display average sales equal to 40. If you put 20, it allocate 20 locations. If you put 50, it allocate 50 locations. So this is the dynamic memory allocation. We can change the statement by using C allocation. This is also possible. P equal to integer star C allocate n comma 2. Here we pass 2 arguments. This is number of location. Then if it is integer, we put 2. Float 4. Here we pass only one value, but it is n star 2. But it yield only one value. We pass one value. Here we pass 2 value. So why we pass the 2 value? Because it is a discontinuous memory allocation. If continuously the memory is available in continuous, it allocate. Otherwise it will give null. But in this case, it may be a discontinuous. The memory location, the required memory available in discontinuous location, it allocate. It will give the address. So then only we give 2 arguments. The 5 comma 2. For example, 6 bytes is there. So 3 locations. Because each location has 2. So 6 bytes is in one location. Remaining 4 bytes is in other locations. So then only that's only we pass. That only we pass 2 arguments. That is n comma 2. Pointer wise array. So sometimes pointers and arrays characters are in similar, but it's not. Arrays and pointers in some cases may be similar, but it has some difference. What are the difference? Just through this example, we come to the conclusion. Main static character a of 6 equal to apple. So it is a character array a of 6. This is a memory mapping for that array. That is apple. It's stored a of 0, a of 1, a of 2 because it is a character location. So it has only 1 by 200, 201, 205. So at the time of declaration, the \0 is a last character because it is a string terminator. So this is apple. This is a address. Then character star s equal to apple. This is also valid one. This is a pointer variable. This is a array variable. This is a pointer variable. It is also assigned because s has only 2 bytes. It may be a character or integer float. All pointer variable size is 2 bytes. So it allocate 2 bytes the name of s. Then s equal to apple. The apple is assigned in any memory. So the starting address is assigned to the 300 because the size of s is only 2 bytes. So it assigned in any location, in any available location apple. Then the starting address 300 is assigned here. If we put printf, the a percentage s a percentage s yes, the a is also display like apple, s is also display apple. In this case both are same. But this example, static character a of 6 apple, character star s apple, a yes, it display a apple s apple. In a previous program we discussed that. So apple, this is also apple. Here we put a plus plus s plus plus. It causes error. We cannot be able to change the base address of that array. You know, what is the meaning of a plus plus? A equal to a plus 1. What is the a? The base address of that array. Example 200. 200 plus 1. A equal to a plus 1. 200 plus 1. 201. That 201 is assigned to a. So the starting address will change as 201. Then next address is 201. So each and every byte has unique address. So we cannot be able to change. This one is 201 because already 201 is there. It is occupied by P. We cannot be able to change the base address of that array. So it causes error. But s plus s, it is possible because it is a pointer variable. S plus plus equal to s equal to s plus 1. That is 300. It is a character type. So in the next location just add 1 byte only. So 300 plus 1, 301. So the new value of s is 301. If we print from s, it display PPLE only. Just cut 301. If we print of percentage s comma s, it display PPLE. It does not just cut a because it start from 301, end with backslash 0. So it causes error. We cannot be able to change the base address of array, but we can change the address of pointer variable.